All right, let's crush an Mtel question. So this one says, use the diagram below to answer the question that follows. We've got this shape here. It says the diagram shows the net of a right cone. Which of the following expressions represents the area of the cone's base in square centimeters? So if you think about these two shapes being made of paper, you could make a cone out of this. And they're telling us basically that if you fold this like triangular partial circle looking thing onto itself, then basically the base of this will line up with the base here. This circle will be the base of the cone, and this will just like kind of sit on top of it, right? So you can see how maybe this could be like a party hat type of thing. If you wrapped it around itself, you can make a cone out of this. Hopefully that's possible to see. So basically, the length from here to here, the two corners of this triangular thing, the length from here to here is the same as the circumference of this circle because it'll sit right on top of it. But they're asking for the area of this circle. So the area equation for a circle is A equals pi times r squared, where r is the radius of the circle. Well, the only measurement we have in this entire diagram is on this triangular partial circle shape, and it's the radius of this circle. You could imagine this being an entire circle, right? We have a partial circle that gives this triangular shape, and we know the radius of this circle. So I'm thinking the formula for circumference could also be useful here. So let's throw that in here. So C equals 2 times pi times r. And then to find the length of this, we're going to use an arc length formula. This is something called an arc length. Like a partial circumference is called an arc, and they're giving us an angle. So your formula for arc length is going to be L equals, it's the circumference formula, so 2 pi r, and then times your angle over 360. So that's basically like the percentage of the circle that you have. So 60 over 360 is a fraction that we can multiply the circumference by to find that fraction of the circle. So it's going to be over your angle. Typically we use theta. I'll just say the angle W over 360 degrees. So that's our arc length formula. So if we can find the arc length here, we'll then have the circumference of the circle, because I'm saying that this length is the same as the circumference of the circle, and from there we'll be able to solve for r, and then we can use r to plug into our area formula. So a lot of steps here, but the key to this problem, to this whole problem, I think, is finding r, because that's what we're missing to find the area of the circle, right? The only variable in our area equation is the r. So we need r of the circle to be able to solve for the area. So we have to figure out a way to find that r. And the way that r is related to this other stuff is that we have to find the circumference of the circle, and we can find the circumference of the circle by finding this arc length first. So it's a bunch of steps in here, but these steps will help us arrive at our answer that we're looking for. So the first thing I want to do is find this arc length. So we're going to use our arc length formula, where L equals 2 times pi times the radius, and here we have the radius of 10, and then times our angle, which is 60, divided by 360. So if I simplify this a little bit, 60 divided by 360 is just 1/6. 2 times 10 is 20, so L equals 20 times pi times 1/6. So arc length is just 20 times pi divided by 6. So that's our arc length. And remember that our arc length is also our circumference for the circle. So now I can use my circumference equation, plug this in for C, and solve for r in that equation. So if I use my circumference equation, our C is now 20 times pi divided by 6. And that's going to equal 2 times pi times r. Remember, we're looking to solve for r in this equation. So I just want to get rid of the 2 times pi on this side, and I'll just do that by dividing by 2 times pi. So when I divide both sides by 2 times pi, the pi's are going to cancel out, and then I can divide 20 by 2. So I get 10 divided by 6, and I can simplify that a little bit. That's just 5 over 3 if I divide both of those things by 2. So that's our R value. And we can plug our R value into our area formula because that's what we're looking for eventually. So area is just pi times R squared, and if we plug 5 divided by 3 into this equation, that's getting squared for, that's our R value, 5/3 is our R value. That's going to give us our area, which is our final answer. If we square 5/3, it's going to be, you square the top and the bottom, so 25 divided by 9 times pi is our area. Looks like that is answer C.